Dry dock. When the ship is in a dry dock, a ship's sides are no longer supported by water pressure. The only things holding the ship are keel blocks, bilge blocks, and side. Hogging. Longitudinal bending stresses could be caused while loading the ship in still water. Hogging is a stress that causes the ship's hull or keel to bend upwards at amidships. Look at the effect when the load concentration is more on the ends of the vessel. The ship structure bends downwards at the end. Sagging. When load concentration is more at the center, the structure tends to bend downwards in the middle. This action is called sagging. The vessel is designed with certain allowable maximum bending moment and shear forces which are tabulated in approved ship stability booklet. The loading and distribution of weights will be monitored by Chief Officer of the vessel according to the prescribed limits with the help of load dicta and stability booklet. He is responsible for minimizing this sag and hog of the vessel. Water pressure. Water pressure acts on the sides and bottom of the ship. If the ship's sides are not strengthened, it will tend to bend inwards as shown. Dry dock. When the ship is in a dry dock, a ship's sides are no longer supported by water pressure. The only things holding the ship are keel blocks, bilge blocks, and side shores. The result is that the sides of the ship tend to bulge outwards and the bottom tends to sag. To counteract dry docking stress, the entire bottom of a ship is strengthened. Localized stress. When a heavy weight is loaded over a small area, or if there is a concentration of weight in a particular area, it causes localized stresses. Localized stress is counteracted by extra strengthening. Fluctuation in water pressure causes in and out movement of a ship's side plating at bow and stern. This movement results in panting stress. It is more pronounced at the bow, which pushes the bow ahead into the water or swell. This stress is compensated by fitting panting beams with a distance of 2 meters between every alternate frames. The panting beams are connected to the frames by beam knees and supported by a wash plate at the center. Side stringers in line with panting stringers are fitted throughout this deep framing region. Breast hooks fitted to support the radiused stem plate and to prevent in and out movement of the side shell. Pounding. Pounding stress occurs at the bottom plating of a ship near the bow during excessive pitching. To compensate slamming down of a ship's bottom, outer bottom plating is thickened and connections to inner shell and inner bottom girder are strengthened. The thickness of plates near the pounding is increased by 30% and transverse frame spacing is reduced from 900 mm to 700 mm. Solid floors fitted at every frame space are welded to the bottom shell and transverse floors are fitted at alternate frames. Racking. When a ship rolls in a seaway, there is a tendency for the ship's side to get deformed. This deformation is caused when the deck moves laterally relative to the bottom structure. This in turn causes the side shells to move vertically relative to each other. Such a deformation is called racking stress. This stress is more pronounced on the corners of the ship due to wave action on the hull. Racking stresses are reduced by fitting beam knees and tank side brackets. But the most effective way to resist racking is to fit transverse bulkheads.